recording. All right, thank you. So today we are going to start or to discuss majorly on quantitative data from the term quantity, okay? Meaning you can quantify. Here you can do computations, you can do calculations, okay? So basically, quantitative data, when we talk about quantitative data, it is majorly or it is numerically recorded, or it is numerical in nature, okay? Unlike the qualitative, where we said basically gives us attributes, okay, or characteristic about maybe a certain data, or maybe a certain data, okay? So under qualitative, we said we cannot do computations, okay? But whenever we have numbers, you can do calculations, okay? So under quantitative data, we have that is a data in numerical form, right? Okay, so quantitative data can be measured, and it's not just observable. Okay, the measurement of data is numerically recorded and represented. We can do some calculations, interpretations, and also presentations of what? Of the results of maybe our calculations. Like maybe if we are doing analysis, if you are given a data set, definitely you can we have some steps which you use maybe to make sense out of the data. Like for example, just to give you an overview of data analysis, okay? Steps. Definitely, you have the data. So the first thing, and that is the step which takes in maybe most of your time. It's the first step. That is data data quality assessment. This is the very first step. Also, some people may call it data scrapping or data cleaning. Okay. Yeah, so this is the very first step where you inspect your data, okay, to check if it qualifies to be used for analysis, okay. So majorly in this, we have some dimensions which you have to take into considerations, like completeness of the data, okay, accuracy of the data, relevancy of the data, because maybe we can't be doing that is a stock analysis, and then the data which you have, it is data of maybe age and maybe sales, okay. Yeah, so you have to check also the relevancy of the data, okay, uh, in comparison to your objective, or for you to attain that is your objective of your analysis, you must have relevant data. Also complete. There is a data which can be presented to you, and at the end you find maybe you only have maybe 20 complete that is fields, okay, or complete data, okay. Maybe or give over a data set which has more than what? More than 1,000 entries. Okay, so completeness of data also matters. Okay, and then the accuracy of the data, and yeah, it's also on this stage where you usually take care of outliers. Okay, yes. Then the second stage now, it's the analysis itself, okay, analysis itself. Like for example, if maybe you have a data or you are an online product selling company, okay, so you might have been experiencing what? Um, that is customers churn or customer attrition. Okay, attrition or customer churn basically means now who used to be your customers are not buying. Okay, from what? From your shop as it was before. Okay, so meaning it's like you are losing that is your customer. So with that, basically maybe you can do that is what we call RCA analysis. And under RC analysis, you'll find different analysis here. Okay, like you have also to analyze the problem. So RCM basically means the root cause analysis. Okay, under it you can do some that is problem analysis. Okay, then solution analysis. Okay, and then also do some recommendation. Then basically this is under analysis. Then after that, now you have what we call interpretation. Okay, interpretation. Now the values, all the your findings, you are interpreting your findings. Like if maybe you have two major variables to show the cause of the problem. Okay, if we have a very strong correlation as to why maybe the customers are treating from consuming your services or products, then definitely that value, all those numbers which you get, you have to do what? You have to interpret maybe if it is to the management or to the board for more understanding. And then the last step is always now the presentation. Okay. Then under presentation, um, here we are talking about now if it is your findings, you can now uh, do them in a pictorial format, or you can visualize that is your findings for what? For better presentation. Okay, yeah, so basically those are the the four major steps of data analysis. Okay, yes, maybe just that was just a heads up, because I know basically you might need at the end of the lesson you might need to do some analysis. All right. So basically, when we are dealing with quantitative data, we'll deal with data analysis. Okay, for you to get the information. So we've said calculations and interpretations can be performed on the obtained results. So numerical data is indicated by quantitative data. Okay, so for instance, data can be recorded about maybe how many users found maybe a certain product satisfactory. Okay, that is in terms of maybe you are collecting ratings and also views. Okay, so with that you can now do an analysis to get the overall feedback. Okay, all the overall review of what? Of your product. Okay, so with that, now with the feedback or with the analysis, you can now either re-strategize if you are performing poorly, or you can also strategize that is to improve or even to to improve your products. Okay, so we have some examples of this of quantitative data. You can see we have that is daily temperature, we have price, we have weight, and also we have income. All these comes in what? In numerical format. Then after that, we also say that under qualitative data, okay, or that is quantitative data, okay, we said now we have discrete. Okay, discrete, remember we said it's that is non-decimal, and then also we discuss about continuous. Okay, I guess I had explained more about this. Okay, so I'll just maybe explain that is in depth. So under discrete, we say this that is takes place only whole numbers. Okay, no floats, no floats, no floats attached to it. Okay, basically we are saying no decimals. Okay, and sometimes we can say it is finite, like you can count. Okay, yes, you can count. Then under continuous, we said this of course adds floats or decimal attached to them. Okay, and yeah, basically can take fractions, can take decimals. Okay, yes. Now maybe let's start with the discrete data. So for discrete data, we've said refers to data values which can only attain certain specific values. Discrete data can't attain a range of values. Remember when I was talking about range, I said range is a good example of continuous data. Like for example, if I tell you to give me the values between 0 and 1, okay? Remember I said that there exist millions and millions of values between 0 and what? And 1. Basically, that's text what? Text range. But for discrete, you can see we are saying that it can't attain a range of values. Rather, discrete data can be, of course, discrete data we majorly use that is bar charts, okay, to present it, okay. Yes. So, like for instance, ratings of a product made by users can only be discrete. Okay. Say that 1, 2, 3, or 4 or 5. Okay. Maybe we can check on examples of discrete data. The first example is maybe the number of students in a class. We can say we have 2.5 students in the class. Okay. Also, the number of chips in a bag, it's countable. And the number of stars in the sky. You can say we have 20 and a half stars. Okay? Yes. So those are just major examples of discrete data. Okay? Right. Let's go to continuous, and then maybe I will receive some questions or maybe some that is comments, or you can add some points. Okay, I might have missed something about the data types. So let's go to continuous. So for continuous data, I guess we've discussed more about that. Let's just see what the slide is telling us. So continuous data can contain values between a certain range that is within the highest and the lowest values. Okay, so the corresponding difference between the highest and the lowest values of these intervals can be termed as what? Range of data. So definitely we know that range, okay, range is given by maximum max minus mean, or it's given by that is the highest minus lowest. Okay. Yes, so like for continuous data can take a range. That's what we are trying to mean. Okay, and then for continuous data can be tabulated in what we call that is a frequency distribution. Okay, so the frequency distribution table can be computed for the range or type of what? Of data. Okay, so like for example, if we are given a population, okay, and of 1,000 people, okay, and you are given the age of all these 1,000 people, okay. No, I don't want to use people because when I talk about people, it's more of countable. Okay, let's say maybe age. You know, age can be expressed in decimal. Okay, so you are given like 1,000 entries, age entries. Okay, age entries, and maybe you want to present maybe this in what, in a frequency distribution table. So with that, maybe you can count, make a frequency distribution table and try to count maybe if you have 0 to 10 years. Okay, how many people do we have? Okay, this is frequency. Or how many people do we have between 0 to 10? Then you can go to 10 to 20, or 11 to 20, 21 to 30, and maybe 31 to 40, assuming the oldest age, or the oldest person here in this list has an age of 40. Okay, so with that, you can now do the count here. Okay, and this is what we call frequency distribution table. Okay, so you can categorize. So you can see within this we have what, we have range. Okay, we have range. Good. So we are saying that it is also it can also be depicted using histograms. For example, the heights of the students in the class can be largely varying in nature. Therefore, they can be divided into what? Into ranges to summarize the data. Okay? Yes, whatever we've done here. So we have some examples, like maybe when we are talking about the height and the weight of students, definitely this will take continuous, will take continuous form. Okay, because you can be having that is a height of 5.4 feet, uh, 5.6, 5.7. You can be also of 6 feet. Okay, so that's height. Weight, you can be of 35.6 kilograms, 50.5, 60.2, 70.3. So at least we can see that we'll take in that is the continuous format. Also temperature, maybe when you are measuring your temperatures, or you are recording your temperature readings, you might find maybe sometimes your temperature can, or the temperature of a place can be that is uh, 22.1 degrees Celsius, 21.6 degrees Celsius. So basically, this it's that is temperature. Okay, that is temperature. Okay, good. Also, we have another measurement, that is the wind speed measurement. Okay, so with this, definitely it will take some it will take continuous format. Okay, yes, and that's all about uh, data types in statistics. Okay, that's all about data types in statistics. Any question before now we can introduce now our topic? Any question or maybe any contribution? Okay, we are all good. If we are all good, thumbs up. You can just do thumbs up on your Google Meet. Right, good. So only 5 response, 6. Okay, 6 not bad. 7, 8, 9, 10. Okay, that's more of 3/4 of the class. So meaning we are all good. All right, thank you. Now we can introduce now statistics. Remember, I had also given you an overview of these of statistics. So definitely here will also not take much time. We'll just go try. I will now from this class, I'll make the class more interactive. Like when I ask what is mean, uh, what do you understand by the term variance? Okay, right? Okay, good. Now, let's continue. So remember, I said that statistics is majorly divided into two or categorized into two major types. Okay, that is the theoretical statistics and applied statistics. For our class, I said we won't go with theoretical statistics because it's more of theory, but you can it doesn't mean you can't learn more about theoretical statistics. Okay, but I will majorly now go with what? Applied statistics. And applied statistics, remember, I said that we have what we call descriptive statistics and inferential statistics. Okay, so under descriptive statistics, we said we have three major measures. Okay, that is measures of central tendency. Okay, where maybe we are talking about mean, mode, and median, the three M's. Okay, then the second is measure of variability. Okay, and measures of variability will that is talk about VS. This is VS and CO. That is variance, standard deviation, and covariance. Okay, and then also remember I said we have also another measure known as measures of asymmetry. And under measures of asymmetry, I said this I will that is we'll discuss it under topic distribution, and basically we'll talk about skewness. Okay, skewness and kurtosis. Okay, we'll deal with skewness and kurtosis. Good. Then under inferential statistics, we'll talk about majorly hypothesis testing. Okay, hypothesis testing. And if you want to learn more, you can learn more about some different statistics. That is F statistics. Okay, and F, we can talk about F significance. We can talk about the p-value. Okay, we can also talk about the p-value and also z score. Okay, yes. Now let's now get into the real thing. Now we are now starting that is our statistics class. Okay, so statistics is a branch of mathematics dealing with collection, analysis, interpretation, and presentation of masses of numerical data. Okay, so remember, statistics is more of it's like a summary or another name for data analysis. Okay, why we are saying it deals with collecting that is collection of data, analysis of data, interpretation of data, and presentation of data. And you can see these are the four major steps which I had discussed when I was talking about data analytics. Okay, yes. And we are saying that it is basically a collection of quantitative data, but not qualitative data. So types of statistics, we have theoretical statistics and applied statistics. Let's go with that is applied statistics and descriptive statistics. So remember, under descriptive statistics, I said from the term describe basically gives us a summary. Okay, basically gives us a summary of what? Of our data set. And descriptive statistics only gives us like one value. Like mean, we get a value. Mode, we get a value. Median, we get a value. Okay, so those are just like one value. Okay, yes. So not like when we are doing maybe more of that is inferential statistics. Okay, so under descriptive statistics, in that is a term given to analysis of data that helps to describe, show, summarize data in a meaningful what way. So basically, it helps us to describe and summarize data in a meaningful way. Okay, it is very simple way to describe data. Descriptive statistics is very important to present our raw data in effective or meaningful way using numerical calculations or graphs or tables. These types of statistics applies, okay, on already known data. Okay, so here you must have that is the data ready. You must have the data already. Okay. Yes, then let's go to types of descriptive statistics or measures under descriptive statistics. I've talked about measures of central tendency and also measures of variability. Okay? Yes. So maybe let's start from this point. I will start with questions. Can someone maybe define what mean is? What is mean? Someone?
Average of the data, the
Correct.
average of the data set. Yes.
That's very correct. Mean is basically the simple average. Okay, it is the simple average of your data set. Okay. What about median? What is median?
Median should be the data that is found at the middle in a given uh, set of data.
Okay. Yes, Wangui.
Yes, I wanted to say much the same thing. It's the values or observations found in the middle of the data.
Imagine, okay, you were close to getting the value, but there is a statement which you are missing to make that definition complete. There
Hmm,
is
right.
one statement you are missing because let me just illustrate. Okay, so let's assume I have 6, I have 2, I have 9, I have 7, and I have 8. So which is our median value? Which is our median value? Wangui?
9.
No, it's
Okay.
7.
We,
7.
we we have to arrange it either in an ascending or descending order, and then we get the middle value from there.
Correct. So that's what you were missing. So now median it's that is the middle value in an ordered set of data. Okay, in an ordered. So you must talk about order. Okay, or in assorted data. Like I don't want to use sort in a ordered data, whereby you can order the data either in ascending or descending order. That is in an increasing manner or in a decreasing manner. Okay, like for example now, uh, we can now do what? Arrange this. So it will be 2, okay, 6, 7, 8, and 9. So in this case, the median is what? The median is 7. Okay, what if I had 10 and here I had 10? What is our median? What is our median here? Yes, Wangui.
It is the average of the two middle values. So you add 7 and 8 and divide by 2.
Yes, so in this case it will be 8 plus 7 plus 8 divided by 2. Okay, so this will be 15, so that will be 7.5. Our median value will be 7.5. Correct. What is mod? What is mod? Yes, Susan?
I think it's the most occurring, like in terms of frequency in a set of data, the most occurring either value.
Or values, right? It can be one or two. It can be
Yeah.
one value or more than one value. So basically, mod is the most occurring value in a data set. Okay, it can be a single value or a multiple values. Like for example, let's assume I'm having 1, 2, 1, 4, 5. So what is our mod here?
1.
It is 1, correct? What about maybe if I have this set of data, 3, 2, 4, 3, 5, 7. What about this? What will be our mod?
2 and 3.
Yes, 2 and 3. What about if I had 2? What will be our mod?
2.
2.
Yes, correct. Good. I guess now you got the concept. Is the concept up to that point clear?
Yes.
Cool, cool, cool. Good. All right. Now let's go and see when it comes to nodes. Yes, I guess. In fact, I'm done with measures of central tendency. Okay. So maybe when doing analysis, um, it is not advisable to use mean to make conclusions. It is not advisable to use mean only to what? To make conclusions. Why so? Why can't we use mean maybe to make some conclusions in a that is in an analysis? Yes, Chris.
All right, thank you. I'm responding from a layman's point of view. So I think the mean from the description that you've said
Mhm.
is just basically looking at the average value.
Mhm.
So if maybe you have a lot of numbers that are skewed to one side,
Mhm.
so it means the mean will be distorted.
Correct, correct. That's the major drawback of mean. That is, mean is affected by outliers. Okay. Like for example, if maybe we are talking about weight of people, and most of us maybe their weight are ranging between 50 and 60. Okay. Then one of us maybe has a weight of 200 kilograms. So when you do the average, you can see now the average of our weight will shift maybe up to 90, meaning we will assume that like averagely everyone here is weight you that is his or her weight is what is 90, okay, which is not the case. Or maybe you might find most of us our weight is ranging between 50 and 70, okay, but we have one person whose weight is 20 kilograms, okay. So meaning now that that small value or that small weight will adjust the center of our weight to maybe almost 40 or 30, okay. So with that it means that is we can't at all use mean only, that is to make decision, because it is majorly affected by that is uh, outliers. That's the major drawback of using mean. Okay, good. Let's continue.
Teacher,
Yes.
if you remove outlier from the weight, can you use that average for making decision or conclusion?
Yes. Now with that, you have to first of all to make sure no data that is no data issues. Okay. If it's outliers, you do outliers, but it is unadvisable when doing making decision. You use all the three what measures. Okay, like you can combine the measures. Say maybe we have average weight of this, our and also the median person. Okay, as this weight. Okay, and maybe we have more than two people who are having the same weight. So at least with that, you have to use what? You have to use all these other that is measures for you to make conclusion. Don't only dwell in what? That is conclude with one measure, right? Okay, good. So I wanted us to maybe have like a break, but I don't know if maybe you can we can just hold on for the next 18 minutes, okay? Only 18 minutes, and then we'll end the class at 9:30, okay? Instead of maybe going for a break and then coming back to finish. So let's just use the next 17 minutes maybe to conclude that is our today's class, okay. But basically now we are just going through that is what we've already discussed, okay. All right. So let's start with the measures of central tendency. We've said that an essential statistical concept is the measure of central tendency. This measure is an important way to summarize the data set without one representative value. Okay, so this measure provides a rough picture where your data points are centered. Okay, yes, so basically it shows us how our that is our data points that is or our data points are centered, okay. And we said we and measures of central tendency, we have common used measures, that is mean, median, and mode, okay. So for mean, we've said basically it's the what? It's the average, okay? It is the simple average. So average value is termed as the mean of a data set, okay? It is very easy to compute. Like for example, let's assume we are having we are having uh, let's say weights, okay? We have some weights, 35 kg, okay, 36 kgs, okay. We have maybe 34, Okay, then we have maybe let's say 33 kg. So we have 1, 2, 3, 4, 4. So let's add another weight, that is 32 kgs. Okay, so definitely here we have what we call n. N, we usually call it sample size. N is what? Sample size. Sample size. N is sample size. Okay, so in this case we are, that is, we are saying that um, uh, N basically is the count of all these weights. It's the count now. So N in our case, we have how many weights? 1, 2, 3, 4, 5. Okay, so our N here will be what? 5. Like we are considering that is a sample, that is a sample size of 5 entries. Okay, yes. Then now for us to get the mean, we have to add all these. We have to add all these weights. Okay, and then that is divide by what? Divide by 5. So let's say the mean of our weight here, okay, will be equal to summation of all the weights. Okay, of all the weights. Let's say these are the weights wi, to that is to basically denote the weights, divide by what? By n. So in this case it will be 35 plus 36 plus 34 plus 33 plus 32, then divide by what? 5. So basically the whatever value you'll get here will be what? Will be our mean weight. Okay, like out of this we can say maybe out of these 5 people we have an average weight of what? Of that value which you'll get. Okay, all right, good. So we have now the steps. These are the steps I've just illustrated here. Okay, so like we count the number of the data values or data entries, and we say it is now n, which is the sample size. Then add all the data values. Let's say now the sum to be what? To be s. Then the mean will be the sum of the whole values divided by the total number of what? Of the values. Okay, yes, that's basically the mean. Then the median, we say that median, the middle value of a sorted data set is called median. Okay, so with that we have to do what? We have to sort maybe in increasing or decreasing, that is manner. Okay, and then the middle value for here, remember we can have when n is odd, when n is odd, and when n is even. Like when the count is even, we usually take the two middle values, add them, divide by what? Then divide by 2. Okay. Then for odd, okay, set of numbers, then we'll only do what? We'll only take the middle, that is the middle value. Okay. Like for example, let me just go back to this example. Okay. So in this case, our count here is odd. Okay, we have 1, 2, 3, 4, 5. Okay, so you can see this, our count is odd because our n is equals to 5. So n is an odd number. Okay, so in this case, we'll just arrange that is our values in a ascending order. Okay, then take what? The middle value. So we have 2, 2. So 7 will be our middle value. What if maybe we have 10 here? Okay. If we have 10 here, then it will be 1, 2, 3, 4, 5, 6. So our count will be what? Will be 6. And n is equals to 6, whereby 6 is an even number. Okay, so in that case, we'll take, let's assume this we've arranged here, we'll take these two, middle values, add them and divide by 2, right? We've already discussed that. So all this explains that.